Yes. And we're back live. Get my phone over here, get the live chat. Again, for some reason, the live chat on the computer doesn't want to load, but I can see the live chat right here on my phone. For those of you in the live chat, if you'd be so kind to leave a comment, that would be absolutely wonderful. And we get started for today. Here's my goal. My main goal, my main objective for today is to get to that 12 o'clock intervention period, because you guys know what day it is? You don't know what day it is? Oh, man. It's time for pre-assessment day. Yay. The enthusiasm in my voice is overwhelming. Yay. See, it was that thing, the intervention period was based on 3 standards that somebody that I never met decided were the standards that we needed to cover in Algebra 2. And they basically said, here are some pre-assessments and post-assessments on Linkit that you need to get done. Okay, if you say so. Boss lady who, runs the show. But anyway, back to this. Just as a reminder, if you did not do that post-assessment, the directions for it are on Google Classroom from May 7th post-assessment. If you did not do that post-assessment, you need to get that done. You need to get that done sooner rather than later. The post-assessment does count against you. It does count against you. So you do need to get that done. Otherwise, it will be marked as a 0. The link is still live in Linkit. The code is all there in the Google Classroom assignment. Make sure you are knocking that out. Today at noon, we will be taking another pre-assessment. This one was actually a bit more painful than the previous pre-assessment that we took. But again, the pre-assessment doesn't count against you. But it will determine whether or not you are placed in that enrichment group or that remediation group. It will determine the activities that you end up doing in the next few class periods. So please make sure that you are getting that. Well, actually, no, we will get that done at the end of this class period. But if you're watching this after the fact, you need to make sure you get that done. I will have the code for you when the time is appropriate. Okay. In lieu of that, I want to talk about the calendar a little bit. Okay. You guys really have no idea how little time we have left in this year. Like you think, we're not even halfway through May. No, we have no time left in this year. First and foremost, do you know what's due on Monday of next week? Progress reports. Last progress report of the 4th marking period. And then we'll be in the second half of the last quarter of the year. But then you have this week, the 24th. That's a shortened week. You got a half day on the 26th as normal, but then you got a 5-day weekend. But now I need you to look at this. When you get back from that 5-day weekend, do you know what's happening the week of June 7th? Senior finals. Now, seniors will be taking their exams during that week. And yes, I do have seniors in Algebra 2. I'm still waiting to get confirmation as to whether or not I am allowed to give everyone their exam during senior exams. Still waiting on confirmation for that. But if we do take senior exams on the week of June 7th at some point, I don't know which day it would be, that means that the week before we would basically be reviewing for the end of the year. It's going to go by like that. It's insane. And then, well, if you do have to take final exams during regular exams, then this would be the week of regular exams. And I believe the 18th is the last day of school. Oh, my goodness, what a year. Anyway, I would like to take a step farther into this chapter. With some of the things that we've been doing, we have been simplifying rational expressions. We have been graphing rational expressions. Now is the day that we take a step towards solving rational expressions. So my goal for today is this. I want to introduce to you the concepts of solving rational expressions. And then right before noon, I'm going to get everyone set up for the pre-assessment on Linkit. And then we will knock that out before the end of the class period. So if you do not already have them out, I'm going to need those notebooks out and open. Oh, goodness. Here we go. Let's get them moved. Move this thing over here. Get that thing up there. There we go. Today is May 11th, and we will call this Solving Rational Functions. There we go. To put it in a very straightforward term, I'm just going to give the first example, and that's how we're going to introduce this idea. First example I have for you is this. 12 over x plus 3 over 4 equals 3 over 2. This entire chapter, we've been dealing with rational functions. We've been dealing with fractions where there are variables in the denominator. This is no different. You have a 12 over x sitting as the first fraction in this problem. This is a rational function. And we have to solve this. Solving would mean getting x by itself, isolating x, figuring out the value of x in order to make this equation true. That would be the end-all, be-all goal of this particular type of problem. Now, with this problem, it is conceivable and more than possible that you could guess and check what the answer should be. You totally could. But that is not the purpose of what I want to show you today. What I want to show you today are two main strategies that you could use to solve this problem. Two main strategies. And of these strategies, you should be somewhat familiar with parts of it. But I want to put it all together into a neat little bow. We are going to isolate x. We are going to get x by itself. Strategy 1. Now, I'm going to give you two strategies, but let me just give them one at a time. Strategy 1 is you are going to combine the fractions, and I'll show you what that means. Then you will butterfly. Now, what in the heck? Butterfly? That sounds somewhat familiar. I don't know what grade you were in. I don't know if it was definitely middle school. I really hope it was, where you were taught some kind of butterfly method of solving equations with fractions. When I say the solving by the butterfly, like some people, and I'll do the motion on the board. I'll do the motion like right here on my screen. But some people are like, oh, the butterfly is like when you would go like mer and then like mer or something like that. And I'd be like, yeah, it's kind of like that, where it's like you got to go down to the lane like that. It is kind of like that. We will get there. I'm going to remind you as to what this whole butterfly method actually is in a moment. But we first have to do this step of combining the fractions. You see, on the left side of this problem, there are two fractions that are being added together. We need to take those two fractions and we need to mush them up. We need to mush them together into a single fraction before we butterfly. Now, in order to bring them together, we need a common denominator. Let me write this out, and then I'll explain why I did what I did. Let me write this out, and then I will explain the why as to what I did. I'm putting part of this in red just to show you what things I am adding into the problem at first. Let's see. Well, right off the bat, I've added 2 fractions into the problem. I have inserted 2 fractions that I am going to be multiplying by in order to alter the way that this problem looks. And I put that in red so you could see where I inserted them. You see, I don't care about the 3rd fraction. I care about the 2 that are being added together. And the 2 that are being added together, well, I can't see it right there. You can see it here. The first one has an x in the denominator, and the second one has a 4 in the denominator. They clearly do not have common denominators. They don't have common denominators. But I can force them to be common denominators. I can multiply that first fraction by 4 over 4, forcing that first fraction to have a denominator of 4x, because it was missing a 4. In the second fraction, I can multiply it by x over x to force it to have the exact same denominator, 4x. It was missing that x. I don't care about what the numerators are missing or what the numerators have in common. I care about what the denominators have in common. And if I force that to happen, then what's going to end up happening? Well, you would have a single fraction that has 4x as the denominator. Once you bring them together, if they both have a denominator of 4x, I can put them together into a single fraction. Well, I just have to clean up the numerator a bit. 12 times 4 is 48. 3 times x is 3x. I'm still on strategy 1, but that completes combining the fractions. That completes combining the fractions into a single fraction. That is what we did earlier in this chapter. We had to add or subtract these fractions, finding common denominators. Now I'm ready for a butterfly. People often mistake the butterfly with like multiplying fractions, but the butterfly is really solving equations when you have 2 fractions equal to one another. And I'm putting this in this red color so you can kind of see what's going on here. I am performing this butterfly step. And what it allows me to do, it allows me to cancel out my fractions, and it turns it into something a bit more manageable. This is the first strategy. Let me bring this back a little bit. Strategy number 1, combine the fractions, then butterfly. We will be well on our way to solving this problem. I don't know who taught you how to butterfly, but when you multiply on that diagonal right there, this diagonal that I'm kind of going back and forth on, 3 times 4x, well, that gives me 12x. And on the right side, if I'm going to be multiplying those 2 together, I'm going to be very careful here. I'm going to do this first to make sure that I'm doing it correctly. When I multiply on that butterfly wing, I don't know if you call them wings or not, but I'm going to put parentheses around the 48 plus 3x. That's going to be in my best interest. Then it turns into algebra 1. Then it turns into pre-algebra. You distribute the 2. Like so. I'm going to subtract that 6x. I'm going to divide by 6. I believe that if you do that correctly, you should be getting 16 right on the dot. And it works. And I'm going to prove to you that it works. I'm just going to leave that up there for a few moments. I'm going to leave that up there for a few moments so people can get that jotted down. When it comes to these problems, we need to make sure we're checking our answer, and I'll explain why that is in a little bit. But I want to show you how you can check your answer. You don't have to write anything down to check your answer. You just need to confirm that this number works. That this number, when plugged back into the original problem, will indeed give you a true statement. I'll go back to the original problem. Just scrolling back. There it is right there. I'm going to go to my calculator real quick. I'm going to plug this junk in to make sure that it actually does work the way that it says it does. Let's see, parentheses. 12 divided by x, which in this case I believe it's 16, plus 3 over 4 should give me, if I hit equals, it should give me the decimal for 3 over 2. Yep, it works. It absolutely works. 16 is indeed the answer. There is a possibility that it may not work. And I will talk about that in the future. I will talk about what you would have to do if it doesn't work in a little bit. Well, let me recap exactly what the heck just happened. Strategy number 1 for solving this problem, combine the fractions, then butterfly. Okay. Find a common denominator. That's what I wrote in red. Once I was able to combine those two fractions, one fraction equal to one fraction, then I can butterfly it. And then it turns into a pre-algebra, algebra 1 type problem that you can solve any day of the week. That's one strategy. Now, my goal is to teach you 2 strategies. You can choose which one you prefer. I have my preference, but I'm not going to share that right away. Although you may be able to figure that out based on something. You'll see. But let's talk about strategy number 2. Strategy number 2. Strategy number 2 is to destroy all fractions. Destroy all fractions. Or, I'm going to put in parentheses, multiply by common denominator. You may have been taught this before. You may have been taught this before in middle school. It's a possibility. I know some teachers that do teach it. I know some teachers that don't. But the strategy that I'm about to show you is quite nice, especially with some of the problems that I have in store for you later on. What this strategy basically gets you to do is to destroy all of your fractions in one fell swoop and go straight into solving the problem using algebraic, or I'm sorry, not even algebraic, but algebra 1 or pre-algebra stuff. To be able to destroy all 3 fractions in one go is just nice. I know how high schoolers think. I know how much you loathe fractions. If anything in math, if you had to make a top 10 list or top 5 list of things that you hate, I guarantee you amongst word problems, you would also have fractions. So I look at the denominators. And in the denominators, I see an x, I see a 4, and I see a 2. Now, clearly, the 2 and the 4, they already have something in common. They already have something in common. But this 4 and the x have nothing in common. The common denominator between them would be a 4x. If I were to multiply each of those by a 4x, watch what happens here. I'm going to show you this in detail. Check this out. I'm going to multiply all three fractions by this 4x. I need you to see what happens. I'm going to write this out long ways. Check this out. Watch what happens when each of these fractions gets their own dose of a 4x. And what I'm doing here is perfectly acceptable. What I'm doing here is perfectly legal when it comes to mathematics. I need you to see what happens. I wrote the original fractions in black. I wrote the 4x in red so that you could distinguish the two. But if you take a 4x in this problem and multiply both sides by it, everything is still perfectly legitimate. But I need you to see what happens here. In the first fraction, the x's cancel. In the first fraction, the x's cancel, leaving you with 12 times 4, which is 48. In the second fraction, the 4's cancel, leaving you with a 3x. And in the last fraction, that 2 on the bottom cancels. But it doesn't cancel that 4 out all the way. It doesn't cancel that 4 out all the way. It cancels out only a 2, so it'd still be 3 times 2x, which is 6x. This is a pre-algebra problem. This is a pre-algebra problem. If you can identify a common denominator to multiply through the entire problem by, it will destroy all the fractions and leave you with something a bit more manageable. Oh, I just got to subtract 3x from both sides and then divide by 3. And I got my answer. I'm hoping it's plainly obvious that this is the strategy that I prefer. But it's not the strategy that you have to use. It's a strategy that works. It's a strategy that will absolutely work. It just does. I want to try another problem together before I give you a worksheet where we're going to try a couple. You'll see. And for those of you online, of course, I'll have a PDF for you once I go to that worksheet. But this strategy does indeed work. Here's what I want to show you another problem, and I want to show you both strategies on it. I want to show you both strategies on it. Just going to stick to both of those. Here is the example that I have going on here. It is P plus 10 over P squared minus 2 equals 4 over P. And if you notice what I'm doing with my paper, I'm splitting my paper in half down the middle because I am going to be doing both strategies, just kind of showing you the visual representation as to what they do. You don't have to end up learning both strategies, but it is good to have them in your back pocket. One might be more advantageous to you over the other, depending on what it is that you're doing. Here's strategy 1. In strategy 1, you are to combine all the fractions, which here they're already done for you. You would only have to combine them if the fractions were being added or subtracted. So you're good there. But then strategy 1 is, well, I'm going to butterfly that thing. Sure. Let's butterfly that thing. P plus 10 over P squared minus 2 equals 4 over P. I'm going to butterfly that thing. Let's see what happens here. I'm going to multiply those two together. And I'm going to multiply those two together. Very strange. If I multiply, let's say, on this wing right here, I end up with this multiplication, which I'm going to simplify in a little bit. And if I multiply along the other wing, I would end up with this multiplication, which I will, again, have to simplify in a little bit. You guys ever been to a butterfly garden? No? In a butterfly, I've been to a butterfly garden. We went recently, and in this butterfly garden, it's absolutely nuts. They have like little like wooden things set up with like a million cocoons all hooked in underneath. And they're all in like various stages and stuff like that. My son actually found a dead butterfly on the ground. Someone had actually stepped on it, and he felt really bad about it, but then he buried it. My daughter accidentally walked out with a caterpillar on her dress. I don't know how you feel about bugs crawling on you. Okay, cool. My son came to the rescue. He has no problem picking up bugs. He will pick up any type of bug in the world. That is the grossest thing to me. But anyway, butterflies. I look at this thing. I got to solve it. I got to distribute. This is an Algebra 1 problem. This is now a flat-out Algebra 1 problem. I'm going to distribute that 4. I'm going to distribute that P. Oh, crap. Do you know what we have? Do you know what we have? Oh, my gosh. You'll see what we have in a moment once I kind of clean this up a bit. First, I had to distribute that 4. Then I had to distribute that P. Holy crap. We have something now. Oh my gosh. Check this out. Look at this. Look at this. Look at this. I'm going to subtract that P from both sides. I'm going to take that 1P squared, and I'm going to subtract it over to the left to give me 3P squared. I'm going to take that 10P and subtract it over to the left to get minus 10P. And that 8 I'm going to leave right there. You have a quadratic. You have a quadratic. We are going to have to solve a quadratic in a few minutes. We've been doing this since September. You've been doing this since the end of Algebra 1. Oh, I love quadratics. They come out of nowhere. They really, really do. We're going to solve that in a little bit. Before we do, I want to show you what this problem looks like when you do strategy number 2. Oh, strategy number 2. If it were me doing this problem, I actually would personally rely on strategy 1. But it is entirely possible to do strategy 2 on this as well. Just make sure that you put parentheses around the top and bottom of that fraction, indicating that the P plus 10 and the P squared minus 2 are separate autonomous terms. I'm going to break out this red colored pencil. I'm going to multiply through the entire thing by the common denominator. And in this case, P squared minus 2 and P have nothing in common. So I'm actually going to multiply through by both of them. I'm going to multiply through, oh, you can't see it. I'm going to zoom in over here. I'm going to multiply through by P times P squared minus 2. Yeah, they can see that on the live chat, just making sure. If I multiply through by that p and that p squared minus 2, it will destroy all my fractions. It will. If I do this correctly, where I take this entire thing and I distribute it to both fractions within this problem, in the first fraction, the p squared minus 2 will cancel, but I'm left with p times p plus 10. If I distribute it to the second fraction, the p's will cancel, but I am left with 4 times p squared minus 2. I want to visually show that. It's weird to see it, but I just want you to kind of, it's an abstract concept to kind of see this thing being distributed to each of these terms. But when you take this p, parentheses p squared minus 2, and you distribute it over here, it's now multiplying that entire fraction. But the p squared minus 2 will cancel, but that extra p is still there. And as a result, it's p times those parentheses in the numerator, which is why this is left over. But then when you go to the second fraction, again, this entire thing is being distributed to the second fraction. The p's will end up canceling, leaving you with the 4 and these parentheses, which is what you have down here. This should look very familiar. This absolutely should look very, very familiar, because now I'm going to have to do the same thing that I did before. Distribute that crap. P squared plus 10p equals 4p squared minus 8. And literally, zooming out, it is the exact same problem. It's the exact same problem, it's just reversed. So I'm going to move everything over to the right side. If I move everything over to the right side, I'm going to subtract p squared. Yep. I'm going to subtract 10p, and that minus 8 is still there. It's the exact same problem. You just get there in different ways. You get there with different strategies. You get there with different visuals. But it's the same work. It just looks different. Ultimately, you could choose to do whichever strategy works best for you. But I got to finish solving this thing. I'm going to kind of walk through the Tucker method one more time, because we've been doing that again and 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 again since September. But we have to solve this thing. A times C gets me negative 24. My two magic numbers are negative 12 and 2, because they multiply to negative 24 and they add up to negative 10. Oh, it's focusing. There it goes. Put my magic numbers in the bottom of the T-chart. That 3p squared is broken up 3p and 3p. I'm going to simplify. Becomes a 1 over negative 4. And ultimately, I get p minus 4, 3p plus 2 equals 0. Look what this problem has turned into. This original problem with a fraction equal to a fraction, after a little bit of maneuvering, after a little bit of manipulation, has now turned into a quadratic, which can be factored like we've been doing since September. And we end up with these two binomials, which we can now solve. We get p equals 4 and p equals negative 2/3. These work. These absolutely work. There is a certain way of checking your answer, but I'm not going to walk you through that right now. These answers work. They absolutely do. I'm going to leave this up here. And I'm going to pass this out to you guys. 2, 3, 4. Let's see what you got here. It's easier to see these. There's 4 in there. So kind of wrap around. And there are 4 in there. Wrap around. Let's see here. For those of you that are online, I'm going to be posting this particular worksheet into the Google Classroom in a moment. Let's see here. Here are you guys. Add from the Google Drive. Let's see here. Oop, I opened up all those yesterday. There it is. PDF for today. Host. Boom. There it is. For those of you in the live stream, obviously it's a bit difficult to see these problems. And obviously for those of you in the classroom, it's a bit hard for you to see these problems because they're printed so small, which is why now for you online, you have the PDF available. And for those of you in the classroom, you have the physical copy of this page. The first problem that I want all of you to turn your attention to is problem number 9 on that worksheet. Problem number 9. I'm going to zoom in on it on my screen here in a moment. I'm going to zoom in on it once I flip this camera over. But let's take a look at problem number 9. Here we go. It'll focus. There it goes. We'll zoom in a little bit more. There we go. I'm looking at problem number 9. They want me to solve this thing. And then check my answer. I'll check my answer when I'm good and ready. You can deal with this problem in any which way you want. You can. The first thing that I would suggest that you do, though, I would definitely suggest to make sure you put parentheses around the bottoms of your denominators. It is important, again, that you recognize the fact that those are single terms. W minus 2 is a term, and W plus 3 is a term that doesn't cancel out just yet with anything. But you can handle this problem in so many different stinking ways. I'm going to put this here. I'll do this right here. Here we go. I'm going to do a butterfly. I don't have to do a butterfly, but I'm going to do a butterfly. I'm going to do a butterfly around those two. And I'm going to do a butterfly around these two. Just being very careful with how I'm drawing those. That's terrible looking. Look at that. Just looks like a blob. But if you recognize how that butterfly actually works, then you recognize that it should be -1 times W minus 2 equals, and I'll move my camera over in a moment. There we go. 4 times W plus 3. It works out quite nicely. It works out quite nicely doing the butterfly here because it is a single fraction equal to a single fraction. Like I said, it just turns into an algebra 1 problem. -W plus 2, because you got to distribute, equals 4W plus 12. And then it's just, I got to maneuver some junk around. Okay. Let me, goodness gracious. Okay, let me subtract 4W and let me subtract 2. There we go. Oh, W equals -2. Yay. Oh, happy day. Now, this problem comes with a small bit of caution. This problem comes with a small bit of caution. Now, let me be clear. This is the answer. This is the answer. It's the correct solution. Nothing will ever change that. But I still have to give you this caution. Tell me, look where my pen is pointing right now. What number would force that denominator to be 0? What number would force that denominator to be 0? Yeah, what about this denominator? Okay, now here's the deal though. You said 2 and -3. Did either of our answers match 2 or -3? Then we're good. Then we are good. Since none of our answers matched +2 or -3, then we're good. There is a possibility of some shenanigans going on where you get an answer that is technically not allowed to be plugged into the denominator. And as a result, if that happens, you said 2 and -3, if we got 2 or -3 as our answer, we would have to disqualify it because it would be a non-solution. That's why in the directions they say check your solutions, because there are some solutions that could be canceled out. There are some solutions that might be disqualified. -2, we're good, because it forces the first denominator to be -4 and the second denominator to be +1. Good. As long as it doesn't give you a 0 in the denominator, fine. We're good to go. Finally, I want to go over number 14. Now, I say finally because that's the last problem we're going to do before you knock out that pre-assessment for me. But I want to take a look at number 14. First thing you got to do with number 14, put parentheses around those denominators. It is in your best interest to do so. Second thing you got to do is recognize something. All 3 denominators are different. All 3 denominators are different from each other. Unfortunately, they have nothing in common. An x minus 1 and x plus 1, they are different denominators. We can't prove that they have anything in common. X minus 2, clearly not. I'm going to do strategy 1 for this. I'm sorry, not strategy 1, strategy 2. I'm going to do strategy 2 where I cancel out all my fractions. You have to look at this very closely because something ridiculous is about to happen. Something absolutely stinking ridiculous is going to happen with number 14. You have to see it to believe it. What I'm going to do, I need a little bit more room for this, so I'm going to put number 14 into my notes. If you want to put number 14 on this page, on the side right there, that is perfectly fine with me. That is your prerogative. But I need a little bit more room. I'm going to put it into my notes. So let me zoom back out. Zooming back out over here. Come on, little paper. Here we go. 6 over x minus 1 equals 4 over x minus 2 plus 2 over x plus 1. There's my problem from number 14. There's number 14 on the page. I'll put my parentheses around there as I did before. Check this out. I'm going to take the entire problem and I'm going to multiply through the entire problem by x minus 1, x minus 2, x plus 1. This is strategy number 2. Strategy number 2, I'm going to destroy all my fractions in one shot. And when I destroy all of my fractions in one shot, then it will turn into a much more manageable problem. Right now, this problem is messed up. I don't feel like finding common denominators amongst these two, combining them and then butterflying. I just want to destroy all of them in one shot and see what happens. So I'm going to take those three terms. We're going to distribute it to every single one of those fractions. If I distribute those three terms to the first fraction, well, the 6 is still there, but the x minus 1 cancels, which is nice. The x minus 1 is now gone. But those other two terms are still there. If I multiply through the second fraction, clearly the 4 is still there, but the x minus 2 goes away. That's kind of nice. And when I multiply the third fraction, the x plus 1 goes away, leaving me with the following. Now, I'm going to give people a moment to copy that down because this is going to be insane. Something ridiculous is about to go down with this problem. I need you to see it to believe it. It is insane. Now, you got to trust me on this one. I'm going to multiply these terms together. You got to trust me on this one. I'm going to multiply these terms together. This would be you foiling. This would be a 2x2 box, what have you. But this would give you x squared minus x minus 2. This would give you an x squared minus 1. And this would give you an x squared minus 3x plus 2. There we go. Oh, let me zoom out. Come on, you. There we go. Much better. All I did was multiply those together. It's easy to see what that thing should be when you actually do the multiplication correctly. But that's not the point of this. I'm going to continue simplifying, and you're going to see some messed up stuff in a moment once I do this distribution. I'm going to have to distribute the 6. I'm going to have to distribute this 4. And I'm going to have to distribute this 2. Here we go. It's about to happen. Everything is about to go down right now at this spot right here. I don't know if I should use red or orange. Oh, what is this? It's like a window marker. Purple. I'll use purple. See if the purple shows up. Kind of, yeah, I'll do that one. Check this out. First of all, look at these two numbers right here. What do they do to each other? They're on the same side of the equation. What do they do to each other? They cancel out. Hold on. They cancel out. So check this out. Hold on. Does that purple show? Kind of shows up. Whatever. Purple. These two cancel each other out. Look at this right here. That negative 6x. They're on the opposite side of the equation. If I were to move that negative 6x or one of those negative 6x's to the other side, I would have to add 6x to both sides. What do they do to each other? They cancel out. I did say this problem was going to be ridiculous. Look at this right here. Now, they don't cancel out. These two terms do not cancel out. But when you combine these two terms, what do they become? Holy crap. They become 6x squared, which would cancel out with this 6x squared. Leaving me with Negative 12 equals 0? Question mark? No mistake was made. No mistake was made. This is a false statement. And as a result of being a false statement, there is no solution to this problem. I showed this to somebody yesterday, and they were like, oh, so we did all of that for nothing. To which I scoffed. No, we did not do all of that for nothing. And they said, well, there's no solution. I'm like, the fact that you can prove that this problem has no solution is the solution. This is a major thing right here. In mathematics, you're so used to answers just being cookie cutter and easy and straightforward. X equals 2. No. You can prove that some problems simply do not have solutions. And it happens when something like this happens, where you end up with an impossible statement. This problem up here, this original problem, there is no such X values that make it true. It can't happen. It is impossible. There's no number that you could plug in for those X's that would give you a true statement. None. Can't do it. It's really messed up. That's what this thing comes down to. That's why I wanted to do this problem. It is just phenomenal in my mind. Okay. Here is the plan. It is 11:55. We have a pre-assessment to get done. Now, the pre-assessment does not count against you. The pre-assessment is simply going to determine whether or not you are in the enrichment or the remediation group. What I need you to do, I need you to go to your Google Classroom stream, and I need you to click on that link that I just threw in there, the test taker link, which will bring you to here. And in a few moments, I am going to give you an assignment code. Just like last time, you type in the assignment code, you find your name, your password's going to be your student ID number, no BTS. And you're going to knock out this pre-assessment for me. Now, again, I remind you, if you did not get done the post-assessment for last time, you need to get that done. Otherwise, it will be counting as a 0. This pre-assessment that you're about to take, like I said, was a bit more difficult than the previous one that we did. Let's just say that way. In fact, I'm looking at the average score amongst all students. The average score for this pre-assessment, the one that you're about to take, the average score was about a 50%. Compared to the previous average score, let me see if I can find that here. Yep, the previous average score for the pre-assessment was 73%. So on average, for this pre-assessment, at least over 20% scored lower, or 20% less points, something along those lines. It's not nice. But again, this is a pre-assessment, You do have the time to do this, so please take your time if need be. I can tell you what my B-Day class did. My B-Day class did it yesterday. My B-Day class, now they did not hit the school average. My B-Day class got a 43.6%, 43.6. Let's see if we can beat them. I think, actually, let me double check something here. Let me see if you beat them last time. For the other pre-assessment that you guys did, you got 67.7. And what did they get? Oh, wait, no. I'm sorry. No, for the previous pre-assessment, you guys got 70%. That's it. You got 70%. And they got 66%. Okay, so yeah, you beat them last time. Nice. Let's see if we can't beat them again. So let me throw this code up here. You're going to type in this code. You're going to get this thing done. You will have the remainder to get this thing done. Please take your time with it. And when you are done, after you have submitted it, if you have not done the post-assessment for last time, please make sure you are getting that done. Jump on any late assignments that you need to get done for me. Here is that code. 001 E58 FW. I'm gonna actually I can't type it there because the chat's not loaded. I gotta type it into this chat right here. Yes, sorry, I just posted. I was just giving a little pep talk speech about it, but I'm gonna type it in right here in a moment. Once I switch over accounts. Come on, this thing. Load the way I need you to. There we go. So the code, if you can't see it on that thing, is 001 E58 FW. There we go. 001 E58 FW. And of course, the test taker link I just posted into the Google Classroom before. Let's see what we can do. Get that thing done. And when you're done, work on whatever you need to make up for me. Okay. For those of you here and in the live stream, there's about a minute and change until that bell rings for the end of the class period. As I kind of foresaw, the results of the pre-assessment were a bit lower than the previous pre-assessment, but I anticipated that because of the severity of the information. Regardless, if you owe me anything, please make sure you are jumping on that Google Classroom. I still have a bunch of emails to catch up on from yesterday and today. So if I haven't gotten back to you yet, I will within the next, within the next day or so as they knock stuff over. Anyway, if you haven't commented in the chat, please make sure that you do so. I am going to leave it open for just a little bit longer before the bell rings, but then I got to shut it down. Okay, that's all for today. We did it. You too. Bye.